Hi, this is Marwa and this is another video about radical expressions. Today we'll focus on how do we multiply radical expressions. Now, we did make another video before about simplifying radical expressions that you need to look at first before we go through this video together. Now, for the first example we have here, we will be dealing with multiplying the radical expressions with only numbers. Like then the next question we will look at what if we have variables. I have here a square root of 8 and a square root of 32. If I have the same index, and this is what we have in the rule here, if the nth root of a and the nth root of b are real numbers, then nth root of a multiplied by nth root of b is equal to the nth root of a multiplied by b. What does that mean? Well, if they have the same index, you can just multiply the numbers under them. What if they don't have the same index? If they don't have the same index, it's not possible for you to multiply. So let's check what we have here. Now, we have two radical expressions. One of them is the square root of 8 and the other is the square root of 32. Well, neither of them is a perfect square. Like square root of 8 is not a perfect square, so I can't just simplify it that way, and 32 is not a perfect square. However, I will need to use the prime factors for this. For every single question we're going to work with, we're going to use prime factorization to make sure that we have the correct answer. Now 8 is, as we know, 2 to the power of 3. And also 32 is 2 to the power of 5. If we don't know that, I'm going to show you in a minute how you use prime factorization to find out. Now, if I multiply them together, I am going to be adding the exponents, which is 3 plus 5. Then I know that it's 2 to the power of 8. If the index here is 2, although you can't see it, so if I can divide 8 by 2, then actually whatever inside is a perfect square that I can take out. So the square root of 2 to the power of 8, when you divide the exponents, 8 by 2, is going to be 2 to the power of 4. Then you simplify it, 2 to the power of 4 is 16. Now, you might say this is easy to work with using a calculator. I agree, but however, you are required to know how it's done, because you won't get the same answer if you have a cubic root or a fourth root. Calculator won't give you the simplest form of a radical. Now, if I have the second question here, the fourth root of 8 multiplied by the cubic root of 32. We can't do the same as we did here because they do not have the same index as we discussed before. So here your answer would simply be not possible. Now let's look at our next question. I have the cubic root of 9 multiplied by the cubic root of negative 24. Well, neither of them is a perfect cube. However, I know that 9 is equal to 3 squared. What about 24? Now, the negative sign will stay with us. The 24, I'm going to factor it. 24 is equal to 2 times 12. 2 is prime, and 12 is equal to 3 times 4, and 3 is prime, and 4 here is 2 times 2, and both are prime. When you get to prime factors, then you're done with your prime factorization. How many 2's do I have? 1, 2, 3, so this is 2 to the power of 3, and only 1 3. Now let's continue with multiplying. This is a cubic root, so my answer is going to be a cubic root. How many 2's? 2 to the power of 3. And how many 3's? 3 to the power of, I have 2 here and 1 here, so this is also 3 to the power of 3. Both of them now are perfect cubes. Don't forget the negative sign. This is as if it's a negative 1, which has a cubic root of negative 1 multiplied by 2 multiplied by 3, so your answer is negative 6. Now, so far, everything seems easy because we have numbers that we're dealing with, and all of them we got to be a perfect squares or a perfect cubes. Now, let's look at something else. In these examples here, we have radical expressions that involve also variables. And most of them will not give you a perfect square or a perfect cube to work with. So let's look at our first one here. I have 50x to the power of 5 and I want to find its square root. As I showed you before, first thing you're going to do is prime factorization. I have 50 which is 2 times 25. Now 2 is prime, then 25 is 5 times 5. Then I know that I have 2 times 5 squared multiplied by x to the power of 5. Now, why are we doing this? We are training ourselves on how to simplify before we see how we are going to multiply those radical expressions. Now, x to the power of 5 is not a perfect square. However, x to the power of 4 is the nearest perfect square, and it's going to be multiplied by x. What did I do? I just broke this down into two things. One of them is divisible by 2, the nearest number divisible by 2 to 5, which is 4. And the other one is the rest of it. So I broke the x to the power of 5 into x to the power of 4 multiplied by x. Now what am I going to do here? I'm going to check any perfect square. I can actually take it out of the square root. 5 squared is a perfect square. Square root of 5 squared is 5. X to the power of 4 is a perfect square. How do I know? 4 is divisible by 2. So when I divide 4 by 2, I will get x squared. I took that out as well. Now I'm done with these two. What about the 2? It's not a perfect square, and the x is not also a perfect square. So what happens to them? They stay where they are under the radical. So I have 2x here. Remember, as we discussed before, if this is a square root, it means I have an even index. I should put a absolute value. Then after I'm done, I'm gonna check if whatever I have inside the absolute value here, the variable I have, if it has an even exponent, then I can take it out. So I will go to x squared. Under the square root I have 2x. Now how does absolute value work? We use absolute value if we have an even index. After I use the absolute value, I check inside the absolute value if the exponent of the variable is even. It means it's going to be positive anyway, so I can take it out. There is one more thing we're going to check for, but when we start multiplying. Now here I have cubic root of negative 250, x to the power of 6, y to the power of 5. Again, I need to simplify the negative 250. So negative will stay, and 250 is equal to 10 times 25. If you choose any other factors, you'll get to the same prime factors at the end. This is 5 times 2, both are prime. And this is 5 times 5, and also both are prime. So if I need to simplify this, I know that the negative sign will stay with me. This is the cubic root. And how many 2's do I have? Only 1. But I have 5 to the power of 3. Now what about the variables? Well, 6 is divisible by 3, so this is a perfect cube, so it stays with me. Y to the power of 5. Well, 5 is not divisible by 3. However, the nearest number divisible by 3 is y cubed. I already took y cubed, so it has to be y cubed multiplied by y squared to get to the 5. So I only broke this into a perfect cube and the rest. Anything that is a perfect cube I can take out. Negative 1, remember, is a perfect cube. I can take it out. So I took the negative sign out. Then 5 cubed, so I can find the cubic root of 5 cubed, which is 5. X to the power of 6. The cubic root, you divide the 6 by 3, is x squared. So I'm done with that as well. Y cubed, you divide y 3 by 3. Well, the cubic root of y cubed is y. What do I have left? Left we have 2. So I'm done with this as well. And y squared. Now, do I need to use an absolute value? Absolutely not, because this is an odd index, so no need for the absolute value. One more question. I have the fourth root of 64 x cubed y to the power of 6. Well, 64 is 8 times 8, and 8 is 2 times 4. Only 2 is prime, and 4 is 2 times 2. Here also 8 is 2 times 4, 2 is prime, and 4 is 2 times 2. So how many 2's do I have? 1, 2, 3, 4, 5, 6. So this is going to be the fourth root of 2 to the power of 6, x cubed, and y to the power of 6. Now how many of them are to the fourth power? So I can actually take it out of the fourth root, well, I can break this into 2 to the power of 4 multiplied by 2 squared. Only this can be taken out. X cubed, too bad there is nothing we can do about it. Y to the power of 6 can also be broken into y to the power of 4 multiplied by y squared. Anything that has the same power as the index can be taken out, so I can take 2 out. The fourth root of 2 to the power of 4 is 2. So I'm done with this. What else? 2 squared? No. X cubed? No. But y to the power of 4? Yes. Fourth root of y to the power of 4 is y. What do I have left? I have the fourth root here of 2 squared, which is 4, x cubed, I'm done with this as well, and y squared. Now, do I use an absolute value? Yes, we do. Absolute value of y. Do we put 2 in the absolute value? No, we don't need to, because it's positive anyway. So the number doesn't need to be in the absolute value, only the variable for your final answer. We are going to start multiplying radical expressions. Now we have 3 questions here. Now there are 2 things you can do. You can multiply first, like multiply 6 by 16. Then you will need to find its prime factors and it will take you longer time. Or you can simplify first. So simplify each of the radicals first, then multiply, or multiply both of them, then simplify. Both cases you'll get the same answer. Now I have the cubic root. I'm looking for the cubic root of 6, which is 2 times 3, and both are prime. So no need to do anything else. And the cubic root of 16. Well, 16 is 2 times 8, and 2 is prime. And 8 is 4 times 2, 2 is prime, and 4 is 2 times 2. So this is going to be 2 to the power of 4. Now I'm going to multiply what's under the radicals. So I have 2 to the power of 5 multiplied by 3. None of them is a perfect cube, so I will need to break that 2 to the power of 5 into 2 cubed times 2 squared, and together they make 5, and that's multiplied by 3. Your answer in this case, I can find the cubic root of 2 cubed to be 2, and under the cubic root I still have 2 squared multiplied by 3, which is 4 multiplied by 3. Then your final answer is 2 cubic root of 12. In here we have the square root of 8y to the power of 5 multiplied by the square root of 40y to the power of 2. I'm trying to simplify first. I know that 8 is going to be 2 to the power of 3, and I have y to the power of 5 here, and that is multiplied by, well, 40. If I want to find the prime factors of 40, 40 is 10 times 4. 10 is 2 times 5, both are prime, and 4 is 2 times 2, and both are prime. So I have 2 cubed multiplied by 5, and that is the prime factors of 40. Then I have y squared. Now we are going to multiply y cubed multiplied by y cubed is y to the power of 2 cubed multiplied by 2 cubed is 2 to the power of 6. Now then this is multiplied by 5, and y to the power of 5 multiplied by y to the power of 2, this is y to the power of 7. I need to simplify this, so I'm going to continue working here. Well, 2 to the power of 6 is a perfect square because 6 is divisible by 2, so it can stay. And I have 5, but y to the power of 7 is not a perfect square, so I'm going to break it into y to the power of 6, which is a perfect square, multiplied by y. Then whatever is a perfect square I can remove from under the radical. So I have the square root of 2 to the power of 6, divide 6 by 2, again this is 2 to the power of 3. And y to the power of 6, so I'm done with this, is y also to the power of 3 that I can take out. Then under the radical 5, y will stay. This was a square root. Now we check for absolute value. This was a square root, so the index is even, so I need to use an absolute value. However, this is odd, so actually the absolute value would stay. The thing that I told you about that you need to check for other than being an odd exponent, if we're multiplying now, we are going to look back at the 2 expressions I'm multiplying together. Now here y was squared, so either y was negative or positive, it would work. Here y was to the power of 5. If y was negative, then this whole thing would have been negative, and under the square root you cannot have a negative number. It will make the whole thing not real. So y being to the power of 5 means that y was not negative to start with. Again, what am I looking for? I am going to look back at the expressions I was multiplying. If under that expression, like under the square root, if I had y to an even power, then it could have been positive or negative, which we discussed before. But if it had an odd power, like in this case, there is no way it was negative. If it was, that will make the whole radical not real. So now that I know that y was not even negative to start with, there is no need for me to keep it inside the absolute value. So this y cubed, I will remove it from the absolute value, and this is my final answer. So let's take another look and talk about absolute value. What am I checking for? If index is even, I use an absolute value. After I use an absolute value, I will look about how reasonable my answer is. If inside the absolute value our exponent is even, then it's gonna be positive anyway, I can take it out. If it's odd, I need to check for something first before I decide to leave it there or not. I need to look at the original expression. If it was odd there, then there is no way it would have been negative to start with. Then I can actually remove it from inside the absolute value. Now let's look at our last question. I will choose a different color again, just to make sure you can see which is which. Now I'm gonna solve this under here. I have a 3 outside. What do I do with this? Absolutely nothing. Leave it where it is. Okay? Then I have the 4th root of 18. I don't have enough space here, so I'm gonna factor 18 here. Well, 18 is 2 times 9. 2 is prime. Then 9 is 3 times 3. Both are prime. Then I have 2 multiplied by 3 squared. And I have a to the power of 9, which stays there. And here the 4th root of 6, which is 2 times 3. Both are prime, ab squared. Now I'll multiply everything under the radical, and that 3 will stay outside, don't forget it. So I have the 4th root of 2 multiplied by 2 is 2 to the power of 2. And 3 squared multiplied by 3 is 3 cubed. I have a to the power of 9 multiplied by a, that makes it a to the power of 10. And there is no b's here, and I have here b squared, so there it is. Now I will check to find anything that has a power of 4, so I can actually find its 4th root. Now what about the 2 squared? No. Don't forget the 3. 2 squared? No. What about the 3 cubed? No. What about the 10 to the power of, the a to the power of 10? Well, a to the power of 10 can actually be broken. So I have here 2 squared, that would stay with me. 3 cubed, that would stay also. And a to the power of 10, what is the nearest number I can divide by 4? Well, a to the power of 8. Then I have an a squared to stay, and the b squared. So the only thing I can take out of the square root, the 4th root, is a to the power of 8. So this is equal to 3. I'm going to take a to the power of 8 out, because 8 divided by 4 is 2. So this is a squared. And under the radical, I will have 2 squared multiplied by 3 cubed, which is 108 when you simplify, and a squared, which will stay with me, b squared. Let's look at the absolute value. Well, I should have an absolute value because this is the 4th root. However, can I remove it? Yes. The variable here has an even power. If it had an odd power, I won't remove it until I check under the original expression. If it was odd to start with, then no need for me to leave it inside the absolute value. So here, no need to leave it the absolute value. Also, the number 3 will be taken out because it's positive anyway. So I have 3a squared, 4th root of 108, a squared, b squared. Now, I hope this has been helpful for you. The most important thing we need to discuss and take care of is the absolute value. You need an absolute value only in case your index was even. After you put the absolute value, you're going to check for how reasonable your answer is. if the variable you have inside the absolute value, like in this case here, I have a squared, it has an even power, then it's going to be positive anyway, I can remove it. If it had an odd power, like in this case here, well, it should stay. However, I will look back at the original expression. If it was odd to start with, then it wasn't negative from the start, then I can remove it. If it wasn't, like if it was only even, like in this case here, then it will stay inside the absolute value. Now, I hope this has been helpful for you. If you have questions that you're solving right now, you're not sure about the answers for, regarding multiplying radical expressions, you can leave them in the comments and I will find you the answer and find it for you. And if you need more details about how to simplify, please watch the first video of radical expressions. Thank you for watching.